Today we plan to talk about the graphs of inverse hyperbolic functions, their domain, their range, and when they exist and how they exist. See, the inverse of any function exists only when the function is 1, 1. If a function is not 1, 1, then its inverse does not exist. And if we know the graph of any function, then also we can say if that function is 1, 1 or not by using a test called horizontal line test. The test is called horizontal line test. Horizontal line test. Horizontal line. What the test says? If every horizontal line passes through the graph at most once, that means take any horizontal line that should pass the graph at most once. That means it may not pass, or if it passes, it will pass through a single point. Suppose at hyperbolic cosine, see this horizontal line. Horizontal line means the line which is parallel to x-axis. See, this horizontal line passes through 2 points. So hyperbolic cosine is not 1, 1. Let's write this test. This test says every horizontal line must pass at most once. If any horizontal line, what its opposite, if any single horizontal line passes through the graph at 2 points or more than 2 points, then that function is not 1, 1. It's simple. So for hyperbolic sine, it is 1, 1. Take any horizontal line, any line parallel to x-axis that will pass through the graph at single point. If your function is 1, 1, then nothing much to do. Your domain and range of inverse function will be just the opposites. So domain of inverse hyperbolic sine is its range, that is set of all real numbers. And what is its range? The domain of hyperbolic sine, that is also the set of all real numbers. If your function is 1, 1, to get domain and range of inverse function, just swap the domain and range of the original function. Then what is the graph? The graph of inverse function is the reflection of the graph treating y equals to x as a mirror. Here we have y equals to x. Y equals to x is a line that passes through origin. So this is our y equals to x line. This is a y equals to x. To find the graph of inverse hyperbolic sine, we will just reflect the graph of sine hyperbolic treating y equals to x as a mirror. So we will just reflect this one with this as a mirror. So this will be somewhat like this, and in this side also. This is our inverse hyperbolic sine. This is our inverse hyperbolic sine. Now we are done with inverse hyperbolic sine. This is our graph, and these are domain and range. Next, hyperbolic cosine. We have already seen this is not 1, 1. Our horizontal line test fails. When a function is not 1, 1, but we want its inverse function, then it is customary to restrict the part of domain which is responsible for not making 1, 1. See here, if we will just restrict this part, we will just remove this part from the domain. So our hyperbolic cosine will be this much. Now take any horizontal line, it will pass the horizontal line test. It will pass the graph at most once. See, if your horizontal line does not pass, then also it is okay. But your horizontal line should not pass through 2 points or more than 2 points. If we restrict the domain to 0 to infinity, the positive part of x-axis, then our hyperbolic cosine becomes 1, 1. In every cases where our function is not 1, 1, we will apply the same procedure. We will restrict the domain to make the function 1, 1. And here the restricted domain is 0 to infinity. So our range here will be 0 to infinity. because we are swapping the domain and range. The domain here will be range here will be domain, but here we will take the restricted domain, that is 0 to infinity. And what is domain? Domain is the range is 1 to infinity. For graph of hyperbolic cosine inverse, we will apply the same. We will plot the y equals to x line. This is our y equals to x. Then we will reflect the restricted part. When you reflect this one will be here. Then you will get a curve like this one. This is our hyperbolic cosine inverse. Next we have hyperbolic secant. This is our graph of hyperbolic secant. The domain is set of all real numbers. Range is 0 to 1, 0 open, 1 closed. We have already seen this. See, this function is also not 1, 1. This will fail the horizontal line test. Take any horizontal line here, it will pass through 2 points. So hyperbolic secant is not 1, 1. So now here also we will restrict the domain from 0 to infinity. Then our graph, then our function will be 1, 1. So what is our restricted domain? 0 to infinity, that will be range here, 0 up to infinity. What is domain? The range of hyperbolic secant, that is 0 to 1. We are just swapping. Then our graph will take y equals to x line. Graph of inverse function is the reflection of that graph, treating y equals to x as a mirror. Remember this one. So we will reflect the restricted part only. Here 1. When you reflect this, you will be at here, which is 1 at x-axis. If the graph is approaching x-axis, here also our graph will approach y-axis when you reflect. So our secant hyperbolic will look something like this. This is our secant hyperbolic. Here this approaches our y-axis. Next we have hyperbolic cosecant. Here it will pass horizontal line test. Take any horizontal line, any line parallel to x-axis, it will pass through the graph at most once. So its domain and range. What is its domain? Domain is the range of hyperbolic cosine, that is real excluding 0. Here also we have real excluding 0. Range is domain. Now for the graph of hyperbolic cosecant inverse, we will take y equals to x-axis line. Then we will reflect this one. So our graph will be something like this one. See, you may say that the graph is same as hyperbolic cosecant. No, that is not the case, because the hyperbolic cosecant and inverse hyperbolic cosecant, they two are different. They may look the same shape, but they have different structure. So inverse hyperbolic cosecant will look something like this one. These are not the reflection of each other, these two curves, the red curves. Therefore their graphs are different, the graph of hyperbolic cosecant and hyperbolic cosecant inverse. Next we have hyperbolic tangent and hyperbolic cotangent. See, this is also 1, 1. Take any horizontal line, it will pass through the graph at most once. Here it will not pass, here it will pass at once. So there is no line which passes through 2 points on the graph. So this passes horizontal line test. So its domain is, that is -1 to 1. Range is domain, the set of all real numbers. We are just swapping. Then for its graph, we will reflect this one by x line, y equals to x. When you reflect this one by y equals to x line, see, this is 1, y equals to 1, this is y equals to -1. They will be reflected to x equals to -1 this is minus 1, this is x equals to 1. So our graph will be something like this one. This is our y equals to x equals to 1. This is our hyperbolic tangent inverse. At last we have hyperbolic cotangent. Clearly it satisfies horizontal line test. There is no line which passes through 2 points, no horizontal line. So its domain and range, there will be just the opposites. The domain is range here, which is minus infinity to minus 1, union 1 to infinity, and range is from R we will remove 0. That is our range of hyperbolic cotangent inverse. And when you reflect this graph about y equals to x line, so y equals to x, this is also y equals to minus 1, this is y equals to 1, they will be reflected to x equals to minus 1 and x equals to 1. See, this curve goes towards, or it approaches to y equals to minus 1. So if you reflect, it will approach to x equals to minus 1, and this curve approaches y axis for large value of y. So when you reflect, your graph will be something like this one. Here also, if you reflect, your graph will be something like this one. See, you must understand what I have done here. This curve approaches y axis, so its reflection will approach x axis. And what this curve does, this curve approaches y equals to 1 line. So when you reflect, that must approach x equals to 1 line. That's it. In negative side, the same thing. The curve that approaches y equals to x axis, here that will approach x axis.